Thank you for being here. I can see the room that is filling up slowly after lunch. Thank you for taking the time. So we're going to talk about space today. My name is Gwen. I'm the global CEO of ZEBOX. So just to talk about ZEBOX in a minute. So we are an international incubator and accelerator launched in Marseille in 2018 by our chairman and CEO of CMA CGM Group, Rodolphe Saadé. So we work at incubating and accelerating startups in the field of logistics, supply chain, mobility, Industry 4.0. So we have 4 hubs in Marseille, France. We're also in the US in Arlington, in the Caribbean in Guadeloupe, and soon to open in Ivory Coast in West Africa. So we are on booth 402, so you guys feel free to stop by and see us. So today we wanted to do something a little bit different and try to inspire as well and go beyond what we usually talk about in logistics and talk about space for a minute. So that was really the goal of this panel, is to talk about space, to talk about something that you're not used to talking every day or to see at those supply chain conferences. And so that's why we're super happy to welcome 3 international panelists, founders running companies, working for the best companies in the space as well, to tell you all about the space industry. So yeah, we're going to get started. Maybe you guys want to quickly introduce yourself. Maybe we can start with you, Joanne.
So my name is Joanne Lecomte. I'm a Vice President, Sales and Business Development for a company called Thales Alenia Space. So we do all things space. So we build LEO, MEO, GEO satellite platforms and payload. We also do all kinds of exploration module. We did ExoMars that landed in Mars in 2016. And we do pressurized module for the International Space Station. So all that good stuff space-wise.
Thank you.
My name is Andrew. So we're a young startup called Gamma. And Gamma is developing small satellites that deploy giant sails, and we sail through space using nothing but the sun's photons as our propellant. So we don't need to carry any propellants, and we can go very far and also pick up pretty high speeds over time. So it's a young startup based just outside of Paris. Thank you.
Thank you.
And my name is Chirol Shah. I'm the VP of Business Development at Gravitics. Gravitics builds extremely large modules for space stations. And these modules could be utilized as space hotels, laboratories in space factories, and more. So really excited to be here. Thanks for having us.
Thank you. I just wanted to start by asking a question to the audience. How many of you guys would like to go in space at least once in your lifetime? Okay, cool. Yeah, me too. And other question, would you guys be okay for a one-way ticket to Mars, though? Yeah? Okay, we need to talk after, though. We need to understand. Thank you. So yeah, we want to talk about this today. And so the space market is something that is not necessarily well known. So the market is today $337 billion and is expected to double in the next decade. And the reason of this panel today was also to talk about logistics and supply chain, which is a massive component of the space industry. And so we wanted to acculturate a little bit on that market with experts. So maybe just to get started, I wanted to turn my first question to you, Joanne. So we're witnessing a huge shift in the industry, especially from a financing standpoint, going from the government leading the pace of the space industry toward more of the private sector. What can you tell us about this shift, what it means for the industry, and what should we expect in the near future?
So interesting statistic is that in 2022, there was 178 in-orbit mission. Out of the 178, 90 were not government. I mean, this is private enterprise, of course, using in some cases government money. And out of the 90, 61 were from one company, SpaceX. So it's almost half. We're reaching half that are of the in-orbit mission that are now commercial. Now, what's going to happen is, I'm going to try to keep it in 2 minutes, but there's so many things happening in the next 2 years in terms of moon exploration. It's fascinating. But if I keep it short, it's the main thing happening is what we call Artemis, the Artemis program from NASA. Some of you may have seen in November 2022, Artemis 1 went up. It was an uncrewed, but it went around orbit around the moon. So soon we'll have Artemis 2, that will be a crew mission. It will be launched in 2024 and very quickly followed by Artemis 3. That will be a crew mission, but this one will not only orbit on the moon, but land on the moon. So we'll have the first woman and first person of color landing on the moon in 2025. But that being said, it's not just the Orion capsule. NASA has started all kinds of projects under Artemis. We have a gateway around the moon in Cislunar. Then soon we'll have also private companies right now working on what they call HLS, Human Landing System, to bring the astronaut from the gateway around the moon to the surface. And then, of course, a moon base that will encompass rovers and all those activities. So that's just for the moon. Then we have Mars Sample Return from NASA that will land on the moon in 2007. And then 2008, we'll have a sample return coming up with all the good stuff that Perseverance, which is already a rover that is on Mars, will bring back. And lastly, and I'll let my colleague talk about it, there's something really exciting called LEO Commercial Destination. To keep it brief, it's like the International Space Station will be decommissioned around 2031, plus or minus. So now there's all kinds of commercial venture to have those labs in space. There's already 3 that have been approved by NASA, and we'll conduct experiments, and we'll talk about it further in the. So it's very exciting. And lastly, really quick, there's the first quarter 2023, we'll have a race to the moon with 3 companies: iSpace with Akuto One, there's Astrobotics with Peregrine, and Nova C from Intuitive Machine. Those are all racing to land commercially, have a lander on the moon first quarter 2023. So it's going to be interesting to see which one of the 3 lands first. So exciting times.
Yeah, I don't want to build off something. One of the things that really excites me is the commercial LEO destinations. NASA said they're going to sunset the International Space Station, and instead of building a new space station, they want to lease space. So, there's a whole host of companies that are racing now to build infrastructure on orbit. Right now, there's about 10 astronauts on orbit, right? 10 humans out of this entire planet are up in orbit right now. We think that by 5 years from now, 10 years from now, that's going to increase to 20, 30, 40. When you get more people into orbit, you're going to need to bring logistics with it, right? The astronaut up there right now consumes 1 apple a day. Well, how many apples is that on a 6-month mission? How do we make sure that he gets that? So we're really excited to see what, how you see the human race increasing their presence in orbit and what that means for everything that we need to do to ensure that they are supported.
I want to talk about pace of the industry for a minute. I was looking at a very interesting stat that was explaining that there has been less time between the moment a first person flew into an airplane and the first crew landing on the moon and the first crew stopping on the moon and now. That means that the pace has been slowing from a space race perspective. Can we talk about how the industry is changing pace right now, and what are the levers that are dictating that pace? Is it funding, regulation, commercial use cases? What do you guys think? Maybe Andrew?
Yeah, I think one of the main things that changed recently, obviously everyone knows, is SpaceX. So by dramatically reducing the cost to access low Earth orbit, it just creates a huge amount of opportunities, including for us, being able to create a startup in a very short amount of time and put something in space. We recently launched our first satellites after 2 years of existence at a very, very low cost. $2 million from start to finish to put a satellite in space with a small team of engineers. That was unimaginable a few years before. And so what that means is there's all these companies coming up with new ideas and new concepts. So it's beginning to tilt to being much more commercial. And the same thing is happening when we're going to the moon and further out. And I think one of the key factors that's really you've got these 3 private companies that Joanne just mentioned racing to the moon. No one's heard of these companies before. I mean, it's incredible. They're going to land a lunar lander on the moon, and there's a race between 3 private companies nobody's ever heard of. And why are they doing that? Because they believe there will be a vibrant deep space economy in the next few years. And I think one of the big triggers is probably going to be as soon as you have a human presence on the moon, then lots of things change, and all that supply chain, all that infrastructure that you need to build is even more important. So I think lots of things are happening very, very quickly, and that's why it's exciting.
I mean, one thing you mentioned, funding. I think one thing that NASA is doing that is very innovative is it's creating PPP, private-public partnership. Because a lot of activities that we know could make money, it's when you start from scratch, it's very, very difficult to have the business case close. So what NASA will do is they'll give study money for at least the NRE, the non-recurring, to be absorbed. And then once the program is successful, then it's up to the commercial company to lease it to the commercial enterprise. So I think that's one of the things that will change. The other thing we need, though, to have a more dynamic space economy is, I hate to say that because I'm anti-regulation, but we'll need to have a minimum of regulation. And the US government led the way with what we call the Artemis Accord. What is that? It's just like, let's say you're an entrepreneur and you realize that there's a helium-3 on the moon and it's worth harvesting, or there's other rare earth mineral. Well, if you land on the moon, how does that work? Can you operate at that particular location when you selected without interruption? Can someone steal your stack and take advantage? So right now, it's like the far west. It's the Artemis Accord are trying to say peaceful exploration, let people do saved zone, but there's only 23 countries that sign, and Russia and China already said they won't respect it. So we're aiming, if you're an entrepreneur, it's kind of a little bit worrisome. The other thing from a regulation perspective is the space traffic management. So right now, if you launch a satellite at GEO, say a higher orbit, it's very well regulated. You have to say where you're going. They give you a frequency. But in LEO, at the altitude of the International Space Station, it's the wild, wild west again. So then if someone does something and it lasts only 3 years in orbit, then do you have a responsibility to deorbit it, either in a graveyard orbit or make it disintegrate? But if there's not enough fuel to do that, then you create this enormous amount of space debris. And it's very worrying because the International Space Station astronaut, in the past, they had maybe 1 or 2 warnings a year to get out of their safety escape. Now it's almost like a warning every month. That's something, and we saw that there's an accident that happened in one of the pipes recently. So we need to have some sort of a world order into debris management, and also if there is debris because of an accident, more and more research on how do we capture those debris.
Jerome?
Yeah, I definitely think, from our perspective that launch, transportation to space is definitely the biggest driving factor. Anytime you can lower that barrier, there's a lot of companies that are kind of sitting on the sideline of the pool, waiting to come in with really fresh ideas. But it doesn't close the business case. It's like, an example I'll give you is if you had to ship something from London to DC and it cost you $5 million, well, maybe only 2 people can afford that. But if that price suddenly started dropping to $1 million or $500K or $100K or $10,000, all of a sudden that business case closes. And we're really excited to see who's on the other side of that we call it flashpoint.
To reinforce on Joel's point, it's absolutely true what you said, because we estimate in average that a mission, about 70 to 75% of the cost of a mission in orbit are launching transportation costs. So the only remedy to that is we have to get better from a technical perspective, also at building in orbit, assembly in orbit, 3D printing. And so instead of transporting your huge antenna on a launcher and trying to make it fit in the fairing, if you can build it in space, that's definitely the way to go. And also maintain when your assets are built, have those little in-orbit servicing that can refuel, upgrade, change antennas, do maintenance. That's the future, maintaining those in-orbit assets as long as you can.
And Andrew, tell us a little bit more about Gamma, because you guys are going more for deep space, right?
Yeah, so we're trying to do something a little bit more science fiction. So we're writing some papers with some people at NASA at the moment, and the idea is to leave the solar system and to put telescopes, very, very far away outside of the solar system, to look back and use our sun as a gravity lens to be able to take very precise pictures of planets in other solar systems. So when you say these things, people's minds people look at you and they think you're completely crazy. So we need to kind of find the stepping stones to get there. And so working with agencies, so we worked with the French Space Agency, we worked with the German Space Agency, we have relations with NASA and others. But in the more short to medium term, what can we do closer to Earth that creates a business case that's interesting? So I'll give you one example, for example. There's all these asteroids that are fairly close. I mean, they're still very, very far compared to what we've done so far in space. But many of those asteroids are valuable rocks, and they can be lots of different things that are very valuable. And so it's interesting. And with the solar cell, you can maybe go and categorize those asteroids and sail close to them, take some photos with something called also a spectrometer. You can see what it's made of and see, okay, which ones are exploitable. And then we become an enabler for perhaps an economy around mining asteroids and then transforming those ores or whatever it may be into something else that has value for the space economy. So these are the things a little bit closer to Earth, where we think there's a utility for what we're trying to build and what we're trying to build our business model around.
Thank you. And yeah, I did my research before this panel, and so I saw that 92% of all the use cases today are around satellite communication or navigation. What other use cases do you guys expect to see in the near future related to the space industry? Like, what are we going to use the space for in the near future?
I can start if you want. Numerous, because if there's one message we can convey to you is that the space industry will, multiply incredibly because I think NASA is not doing a good job at explaining what CASIS do. CASIS is renting commercial space or commercial experimentation on the International Space Station. And since they have started doing that, I mean, I can give you thousands of examples, but the one that are the most important for me, Redwire, is a company that rented space, and now they're growing human tissues on the International Space Station, and with the goal of eventually doing organ growing. So you can grow a pancreas or grow a liver in space because it's easier under microgravity and vacuum. That's one example, having those biofactory. But the amount of pharmaceutical development that have been done by growing crystal in zero gravity is immense. So there's a lot of medication that people use on Earth that were actually bioengineered in space. And not just from a pharmaceutical, but from a pure material perspective. To do fiber optic, you need certain types of material that are excellent to be built in space, and also semiconductors. So you have this whole industry. And another industry that people don't talk enough is how to grow food and recycle water. And sometimes people say recycle your own urine, but it's true. Eventually, people will have to clean water in space. And one example I can tell you that have huge repercussion is 10 years ago when they started to grow food, in space, they realized that the plants were producing a really large number of ethylene and therefore causing more virus and bacteria. So there's pure system completely new to recycle or manage ethylene that has been done in space. And now it's being used in supermarket to increase shelf life of bananas and fruits and also to winemaker to prevent fungus on wine. So there's a lot of those. This is just at the beginning, but when those business cases close and are proven, we're going to see those major factory in space.
Tourism?
Yeah, I was going to say, I'm excited for people in space. Everybody raised their hand in here when they said, who wants to go to space? Space hotels, space factories where people can work and live in space. I'm 35 right now. Maybe by the time I retire, one of the options might be to retire in space. When we're talking about really far advanced things here, the launch costs coming down is a huge catalyst for some of these things that seem really sci-fi. Growing organs in space, come on. But the business case starts to close, and we have this unique microgravity environment around us to leverage. So we're really excited about growing humans in space.
So when you say tourism,
human presence, sorry,
tourism in space, for example, is this something that in our lifetime here, is that something that we might experience?
Definitely.
Absolutely. Yeah, absolutely.
100% or 20%.
That's my personal goal, so I'm going to do everything that I can to make sure I make it into space.
As long as we don't screw things up with the debris. No, we need to be able to get through the debris, and that's an important factor. But I mean, by the time you're 80, your bones are going to be hurting. Wouldn't you love to be retiring on the moon? Sort of soft, less gravity, less pain. If you fall, you don't break your hip. I mean, it's a great place to live.
But Gwen, it's already happening not to make publicity for a company from Houston. There's a gentleman in Houston, Texas, Axiom. So Axiom has already the contract to be attached to the International Space Station. When it's decommissioned, it will continue the Axiom module as a free flyer, but it's already decided in the business case that you'll be spending a week in cislunar orbit, which some people prefer to what you saw with Jeff Bezos, where you do, this kind of 3-4 minutes where you see the curvature and you're down. There's a market for people that say, no, I want to have a full week of experiencing microgravity and a week in space. So this is already in the business case of Axiom.
It's coming.
Yes.
Okay. So we have an audience today of supply chain experts, transportation experts. So what are the current challenges that are being faced in the space industry related to logistics and supply chain? Maybe Gerard.
Yeah, I can start with that. It's really interesting. I gave the example earlier of the International Space Station. One of the astronauts on there, prefers apples. Well, there's somebody at NASA whose job it is to think about how many apples they can get to the International Space Station, when they're going to get it there, and how many they need to get, how much is it going to weigh. There's a whole lot of calculations that go behind it. That's just one example. But once NASA moves away from managing that role and says, hey, commercial industry, we want you to come in. For example, Axiom is building their own commercial space station. Well, Axiom's going to have to pick up that job. And the way that I like to think about it is nobody can go to space alone. So understanding, the space companies that are innovating in the future, we need to look around and see where the innovation's happening here, that we can partner up and leverage the innovation that's going on here to help create those business cases and ensure that logistics in space are closed.
We also we're talking about logistics in space, but there's logistics for space on Earth, which is also a little bit challenging. And we've been living through some of the complexities. And basically, you're working with a supply chain, lots and lots of very small mum and pup shops doing very, very small pieces, and they're not very modern by any sense of the imagination. And so it's a huge challenge. And if you're trying to build things fast, then you hit those roadblocks quite often. So I think we need to fix logistics of space on Earth first.
And I think from a logistic, we share a common we're talking about pressurized module. Now they're not, the diameter requested is not 5 meters, it's 8 meters. So it's just a specific example where if you have this huge module coming out of your factory, and ours is in Torino, north of Italy, in Turin, how do you bring this 8 meter it's going to be a combination of road and ship to the launch site. The larger it becomes, the more the logistic is horrible. So it's like either we need and experts like you to actually try to solve those problems, or eventually even think about building new operation next to landing site to make it easier. But I think one thing that COVID showed us is that we had in space, from a supply chain perspective, said, okay, now we're going to move away from space component to commercial components like semiconductors and what have you. But then with COVID, what happened is the supply chain was even worse than the space-graded components. So we came full circle, and I think there's no other solution than multiplying your supply chain to stop avoiding having those bottlenecks. And when something happens, then the whole critical path is linked to one single manufacturing product.
Gerard, you wanted to add something?
Yeah, no, we definitely concur with the same thing. We're not feeling it at the component level, but we can definitely relate to, the logistics of transporting an 8 meter, or for those that are in feet, it's about 26 feet, a giant module. Roadways and power lines don't let you get. We're building in Seattle, and we're going to be launching out of Cape Canaveral in Florida. So that's probably the largest logistic problem. But sailing around is also an option. But in general, just logistics of how we ensure mission cadence, mission assurance are really, really, really important parts of how we do business.
And from a logistical standpoint, from pure like supply chain and logistics perspective, what are the specificities from the space industry that are like constraints maybe and challenges that we can imagine here on Earth today that don't exist with other in other industries? Like you were giving the example of Apple's, for example. Like we're talking about really precision logistics here. Is it a specificity of that industry, and is that something that we're going to see more moving forward?
I think, there's the environment is obviously different. So you have vacuum, temperature variations, radiation. These are things you don't think about too much on Earth. The one advantage in space is you don't need to deal with customs at all. So there are some advantages, but mostly there's these new technical hurdles that you need to kind of get comfortable with.
No customs yet.
One example we can mention in Artemis is the collaboration between Lockheed Martin and General Motors. So logistic in space right now is to have rover that will not do like the Apollo mission. They used to do just about 4 miles. Now we want rover that will go very long distances and being autonomous. So GM, especially the military side of GM, they have extreme experience in the rugged terrain. But most importantly is the nights on the moon are 14 days. 14 days of night and 14 days of Earth days of daylight. So what happens is you need to have batteries that will have to operate for 14 days in temperature that go from minus 260 to plus 260 approximately during the day. So you need to have experience in batteries and in propulsion and all that stuff GM has. So it's just one example of this perfect synergy between Earth company and Lockheed putting their energy together to put the best practices together in one particular product. Just one example, but there's many.
I'll also add to that, kind of a different perspective. Mission, when you talk about going to the moon or going to Mars, there's a finite window that's open for you to launch your payload, right? Going to that orbit. And everything that you do as a program manager is building down this crazy long schedule to that one launch time. If you miss that, you're going to have to delay your trip, right? So it's very important that from the supply chain perspective, you're hitting all of the marks to make sure that your products are delivered on time, your materials that you have that you're building with are available, and that you have it in-house to do it. So terrestrial logistics for space, mission assurance is a critical aspect.
Go ahead, Joanne.
Maybe something that is interesting, like collateral to your question, is sometimes business cases are completely opposite, whether it's from Earth or a space perspective. And one topic that is very frequent right now in space is having a space data center in space. So the logic is completely different. On Earth, the initial cost of a data center is very low, except for the real estate. You have low employee, you build the computers, but then the long term to the power to cool and to operate is very heavy. In space, it's the opposite. Real estate is free, but the cost of launching is extremely hard. Important. And then the maintenance, well, in space, cooling is free. And there's no cloud between your solar panel and the sun, so the energy costs are very low. So it's just kind of a good example to say that one is completely inverted to the other. And there's a lot of ESA, which is the European Space Agency, is trying right now with Thales Alenia Space to compare the business cases. And from a carbon footprint, which one is more efficient? Data center on Earth or data center in space, and the jury's out.
A question that I believe the people in the audience might have as well is it possible to transform into a space company, into a company that is looking into space, or do you need to be some sort of purpose-built company to enter into that space?
Yeah, I'll say that right now is the time where if you are not a space company, you can definitely enter the market. Space inherently is very difficult. I'm not going to say that it's easy for anybody to become a space company, but the strength lies in partnerships. Nobody can go to space alone, right? I don't think anybody has done it by themselves. So if you've got a critical, value proposition, partnering up to get into space is the best way to do it, in my opinion.
Yeah, I would completely agree with that. And to give you an example, my background is not from the space industry. And we have quite a young team, a small team. And so we've partnered with a lot of different agencies and different people to get the expertise we need. So we probably have 100 people who are experts in their fields helping us out at each step of the way. And the industry is very welcoming to that as well. If you're trying to solve someone's problem or you're trying to do something that's going to move the industry forward.
Completely agree. And to build on that, there's one specific example where it's kind of a scratch my back, I'll scratch yours, because there's something we do from a space perspective with CMA, the French freighting company, and the CNES, C-N-E-S, it's the French equivalent of NASA. So they team up together for this strategic partnership where from a smart shipping perspective, space company can help because they can tell you what the current is, the wind, make weather predictions. So from a freight perspective on Earth, your whole shipping has extra data to make it even more efficient. But then conversely, space can totally take advantage of the expertise of CMA because of what we mentioned earlier, just getting this large piece of equipment from, in our case, from Torino to California, where CMA is an expert in point-to-point logistics. So it's to a point where not only can they help us with that, but the sky's the limit, or space the limit, I should say, because we can even maybe ask CMA at one point in time to choose the launcher as well. It would just be an extension of the point-to-point and deliver a piece of equipment in space with potentially also in-orbit services maintaining there as an addition. So it's one example of complementarity of best practices for two companies that were not supposed to work together that found a common goal where everybody can pinch in.
Maybe a question as well related to this one is, how do you get started? Andrew, you mentioned that prior to founding Gamma, you were not in the space industry. What is the right point of entry to start documenting oneself on the space industry? And it feels like a very technical space that is also widely regulated with a lot of constraints. So as a corporation or an individual, what is the right point of entry?
I mean, everyone has their own story. So for me, it was a little bit of a random walk, but I just felt there was just such a huge opportunity in deep space, and I had to do something for the future that's coming quite quickly. I think if you're a corporate company today and you're solving someone's problem on Earth, I guess the starting point would be to say, well, does this make sense to solve a similar problem in space? And maybe just start to have a few conversations with a few people in the industry and see where that goes. I mean, it is a little bit of a random walk at the beginning. There's no obvious use case necessarily. But I think there will be lots of opportunities, and fundamentally, the space industry is very, very small, and it's growing fast, but the number of people in the space industry is very small still today. And we need a lot more people to enter the space industry to make it as viable and as vibrant as we hope it will be.
Totally agree with that. And maybe some specific sources for people to start is if you go on the NASA website, for example, there's a big program called Next Step. And Next Step is the NASA's reaching out to the industry on all kinds of area of expertise when we'll need to grow the space industry. So it's called Appendixes. I think now they're up to Appendixes P, but it goes for anything from do you have any ideas of how to exploit regolith, the mineral on the moon, in situ exploration, robotics, analysis, anything from a production of, again, the sky's the limit, but it gives you ideas and numbers to call, and at least some of the mission, and then it says who's leading the mission, and then you can have an entry point there. There's also another thing that NASA did. It's called the CLIPS, Commercial Lunar Payload Services. So NASA doesn't want, and that's why those companies I mentioned, like Astrobotic, Intuitive Machine, NASA doesn't want to own the lander. They want to pay per use. And those companies, now that they have the lander technology, they're contracting with all kinds of private industry to, actually populate the payload that will be on the moon, but they also need all kinds of level of expertise to as those mission progress. So the CLIPS, there's about 7 companies. You can look at them online. They are crying for expertise in so many domains.
Yeah, I'll give a slightly similar analogy to what Andrew said, which was, come and talk to the space companies. We're always in search of innovation. I'll give you an example. We're looking at, propellant depots in space. There's a lot of smarts here on the ground on how propellants, consumables are moved around, how they're stored, how they're accessed, the information behind it. That's all valuable tools that have already been solved, right? That problem has already been solved. It's a matter of applying it to space. And so I think that there's a lot that, I mentioned earlier, there's a lot that this industry has to offer. It's a matter of connecting and reaching out.
Yeah, in that sense, it feels quite similar to the tech or the startup ecosystem where, because it's like trying to do something truly disruptive, people are not competing that much, but collaborating a bit more, right?
Yeah.
Another question, a quick one that I had, mainly for you at Gravitics and you at Gamma. From the outside, it also feels like a very capital-intensive endeavor to launch a space tech startup. Is that the case?
So I'll start off by saying that it is very capital intensive. We're coming at it from a different perspective, which is that we're building space stations, and they tend to be.
It just sounds capital intensive.
It is capital intensive. So you got to be very sure that the business case is going to close. But to kind of build on that, it's like anytime you do this capital intensive endeavor, if you go in with the right partners, you can definitely make it happen. So that's my perspective on this.
I'll take the opposite perspective, which is it's surprisingly less capital intensive than what we would have anticipated. So as I mentioned earlier on, we raised from public sources and private sources about 2 million euros, and that's financed the entire team for 2 years to put a satellite in orbit, which if you'd asked me a few years ago what it would have been and what I would have guessed, I would have said 20 million or 50 million. I mean, 2 million is still a lot of money, but it's nothing compared to what it would have been a few years ago. And that's not only the launch costs are going down, but also there's standardization and miniaturization of components. So you can basically buy things increasingly off the shelf to integrate into your satellite. And the last thing, which is really important, is that you have a phenomenon whereby you're willing to take more risk as a startup because you want to go very fast. If you're a space agency building something, the requirements are so much higher because you need to gold plate things and you need to make sure that it's going to work. I'm not saying we don't care, but our risk appetite is much higher, and therefore we can go a lot faster. And you realize when you look at the requirements that are typically required for a space mission, that a lot of them are maybe not that necessary. So you can really reduce the requirements dramatically as a startup, because also we're not taking people on board. And that's maybe one of the biggest differences between what Gerard is talking about and myself.
Yeah, I definitely want to hone in on what he said, which was leveraging commercial best practices, right? I'm not NASA. I don't need a 100,000-page requirement for a toilet, which there probably is. So, we can find really creative ways for rethinking how the basic things are done, and that drives our costs lower. It's still very expensive to make a mistake, but as he said, launch prices going down is going to help some of the new entrants coming in.
But I think also, Gwen, if I should say, it's important when you have your startup to have the right partners. I can give you an example of Luxembourg is one area in Europe where there's a lot of venture capitalists that are trying to, kind of offset for Europe what the venture capitalists are. And there's a company I can mention, they call REV, R-E-V. And the people that had the idea, basically, they want to do like some sort of a space shuttle. It would be a lab that will go in orbit, but it will come back. So you do your experiment, you bring it back to Earth. And very quickly they say, we don't want to be in the business of doing the engineering for the lab. So they gave that to Thales Alenia Space. But they say, we don't want to be in the business of also operating it. So they found another company called Space Cargo Unlimited. So now they all have turns. The inception, the guy that had the idea, he outsourced the vehicle and also outsourced to a company that, a startup as well, but that could take care of the service part. So I think it's always... Funding is always large, but if you have the right partner, you can minimize the overall cost.
Thank you. Guys, if you want to ask questions, feel free to use the QR code as well so we can see having them popping in here. We have about 7 minutes left, and I wanted to kind of finish on an inspirational note. As a human, I'm quite curious, and I'm just wondering what I should expect to see in the next, I would say, 25 to 50 years. What are we going to see in our lifetime? Are we going to go to space? What are we going to see?
I think you're going to be taking photos from space and sending it to your family.
And post them on Instagram.
Posting it on whatever will be after Instagram. But I think there's these really exciting things that are happening. And one of them for me is around removing some of the dirty industry on Earth, perhaps, and putting it in space. Because you have a lot more... You can go and mine asteroids. You can go and produce things in space. You have robots that are going to be building infrastructure in space. And you'll have a chance to actually bring stuff back down to Earth. And that will be clean. It will be fully solar panel, very clean energy. And so that means that we can preserve the planet in a much more sustainable fashion. So that's one of the things for me, at least.
Yeah, I see. Well, in 25 years, first of all, we'll have the first landing on Mars. But I think in order for that to happen, I think the lunar economy will have grown tremendously. So in 25 years, I can see without science fiction, a lot of people working in cislunar or in orbit around the Earth, doing all kinds of experiments. We'll have a moon base, and we'll have people that frequently will go back and forth, different types of expertise, and it's coming. I really think it's not science fiction. In 25 years, it will be reality.
Yeah. So this is a space discussion, so if I didn't give you a sci-fi vision, then we haven't done our job. At Gravitics, I mentioned we're building extremely large space station modules, and we're really excited to do that. But our North Star, our company's vision is in 10, 15 years, we're going to build large rotating space stations that allow you to have artificial gravity. For example, the billionaire version of Gwen that's going to go into space today, he's going to have to use a vacuum for a toilet. He's going to have to drink all of his water from a pouch or meals from a pouch. It's not exactly enticing or convincing you to go today. But with a little bit of artificial gravity, you can now have a dinner on a table. You can pour a glass of wine, and it stays there. It doesn't fly away. You can take a shower. It's a much more exciting experience. So at Gravitics, we're excited for a future where we see hundreds of people living on orbit, and we're not too far away from there.
If I can that's such a good point you brought up, the gravity, because if you look at the Kellys, the twins, they found out that he was losing 1.5% of his bone mass per month in orbit. So that's 12% more per year. So gravity is a huge problem, not only for bone mass, but also, they don't know why, but when they came back and they compare it with this twin, his telomere at the end of the DNA had shortened, which is a catastrophic because it shortened your life expectancy. Apparently, they grow back to normal after a year, but that's still concerning. And also eyes, the eyeball gets deformed. So if we don't find solution, you'll have people going to Mars that will break a leg the minute they do their first step on Mars and be completely myopic. So it's a serious problem.
A fun fact, the astronauts today on the International Space Station, to fight that, they work out about 2 to 3 hours a day on a bike. So they lose muscle mass almost immediately. So to counter that, they start working out.
No, I wanted to maybe finish the panel as well with one question more related to entrepreneurship. What would you say to a founder today that is thinking about launching a space-related company? What would be the best advice you could give to that founder?
So Gravitics is a venture-backed startup. And so we'll tell you right now, you got to keep trying, and then partner up. Find opportunities to partner up. That is your greatest ally. As I said earlier, nobody goes to space alone.
Yeah, I agree. So partner with maybe an existing space company, but it doesn't have to be one of the, I call ourselves the dinosaur, like us, Airbus, Lockheed, Northrop Grumman. I think, to your point, smaller companies are more nimble. New space, we call them, could have all kinds of need for subject matter experts. So that would be, but also I would approach those companies with a specific mission that has to be accomplished in space, and come up with some sort of a partnership or solution or value added that you can bring to an already known space mission.
Yeah, I would say, you can afford to be very, very science fiction-y in your thinking. And what I mean by that is, if you have a really crazy idea, you'll find within the space community people who say, hey, that's really interesting. How can we make it happen? And then you walk through the possibilities, and then suddenly maybe you have a viable idea. So I think you can afford to be thinking 10, 15 years ahead. What is the deep space economy going to look like? It doesn't exist today. There will be a lunar economy. There will be a Mars economy. Think where the puck is going to go and try and build something for them. And good luck if you try.
Thank you. Well, on that, Andrew, Joanne, Gerald, thank you so much for your time. Thank you guys for attending. And yeah, wishing you guys a great day. Thank you.
Thank you.